Hello everyone. Today we will discuss how electricity can be carried to the consumers via electric power systems. So what is a power system and what are the main parts and functionalities of a power system? Let's have a look at a representation of a traditional power system. A traditional power system consists of three main systems: the generation, the transmission, and the distribution system. We call it traditional because the generation of electricity is centralized, meaning that only a few large power plants are involved. The generation system comprises the power plants that supply power to the system, also called generation stations or generation units. Some examples of traditional power plants are thermal, hydro, and nuclear power plants. The transmission system is made up of transmission lines that transport the power from the generation system to the distribution system. Typical voltage levels for the transmission system range from 10 kilowatts to 1100 kilovolts. The distribution system is the network that feeds power to the load. The load represents power consumption of the system. It contains households, hospitals, commercial buildings, and small to medium sized industries, among others. Typical voltage levels for the distribution system go from 120 volts up to 10 kilovolts. The voltage levels of the transmission system are higher than those of the distribution system. You might wonder, how does a voltage level change from one system to the other? In power system, this is done mainly by means of transformers. A transformer uses electromagnetic induction to transfer electrical energy between two or more circuits. A typical transformer consists of two windings. Depending on the ratio between the primary and the secondary winding, the voltage will be increased or decreased. Transformers are generally placed at substations. A substation contains many elements that are important for keeping the system operating between the admissible boundaries. Some of these elements are transformers, capacitor banks, switches, circuit breakers, monitoring equipment, among others. In short, an electric power system is a network used to supply, transport, and distribute electric power to the loads. Let's have a closer look at the diagram. Notice the direction of the power, denoted by the arrows. As you can see, there is a unidirectional power flow, which means the generation occurs only at the generation side of the power system and consumption only at the distribution side. This is one important characteristic of traditional power systems. But there are some other characteristics that are worth mentioning. For example, most power plants are controllable and large voltage is increased or decreased by means of transformers. Large power plants operate on an alternating current. Let's now have a look at how a future power system could look like. Please notice the differences. First, you might observe that there are generation units located at the distribution system. They are not centralized as in the case of traditional power systems, but distributed. This is known as distributed generation. Some examples are photovoltaic plants, small wind turbines, and fuel cells. As you can see, the power flow not only goes from the generation system towards the distribution system, but now there are power flows going in the opposite direction as well. This occurs as a result of distributed generation, particularly in the case when more power is generated than consumed. You might have also noticed the presence of large consumers, such as electric vehicles, and also the presence of intelligent nodes, or in other words, nodes in which smart grid concepts will be enabled. You have probably heard the concept of a smart grid before. This term has been used for many applications. In this course, we use the definition of the European Technology Platform of Smart Grids, which says a smart grid is an electricity network that can intelligently integrate the actions of all users connected to it in order to efficiently deliver sustainable, economic, and secure electricity supplies. The users can be generators, consumers, and those that assume both roles. The word intelligently means that the power system employs monitoring, control, communication, and self healing technologies to enable a power balance between generation and consumption. Let's summarize some of the main characteristics that power systems will likely have in the coming future. First, a high percentage of power plants will be driven by uncontrollable sources as opposed to the controlled centralized power plants, mostly driven on fossil fuels. Secondly, a considerable percentage of generation units will generate direct current, as opposed to the large power plants which generate alternating current. Additionally, a considerable number of generation units will be based on renewable sources and will be of small scale located at the distribution system. There will be bidirectional power flow, for example, when more power is generated at the distribution system than consumed. Storage will play a major role due to the uncontrollable sources. Finally, smart grid concepts will be introduced to balance generation and consumption. In this lecture, we discussed the main parts of the traditional power system and we got an impression of how the power system of the future could look like. Could you think of the advantages and disadvantages of the power system of the future?